Hello and welcome. In this problem, we are going to compare three different ways of producing heat. One is by joule heating through electricity, which basically means electricity passing through a resistance, electric resistance, and it's converted to, it produces heat at 100% efficiency. Heat released from natural gas, that's basically burning natural gas as you do in your, most of the time in your house on a stove. And heat release from gasoline as in your car. Each three methods will be assumed to be 100% efficient. That is, you're getting all the heat that is produced or generated is usable. Now we have to compare the prices of these three options. It seems weird that there are three different options. The prices should be based on the same type of unit. But unfortunately, that's not in the marketplace today. Electricity is sold in dollar per kilowatt hour. It goes from 10 cents to 30, 40 cents a kilowatt hour. Natural gas is sold in dollar per therm. Another weird unit. A therm is like 100,000 BTU. And then gasoline is sold in, as we all know, in US at least, gasoline is sold in dollar per gallon. So very, very inconsistent units for energy. Here is a cutout from a bill. As you can see, natural gas is in therm and electricity is in kilowatt hour. So obviously, our first order of business should be to convert, how much is, say, 1 kilowatt hour is how many million joule. 1 therm is how many million joule. And then we'll also need 1 gallon is how many meter cube. That'll be the start of our work. So first thing first, let's go and pick up those numbers from the unit converter. So we go to the unit converter test step, and first, let's say we want to find out, convert kilowatt hour. We know it's unit of energy. We can go there, and as you scroll down, a kilowatt hour will be right here, and we can go directly to million joule if you prefer. Kilojoule. So at the top we have all the SI units or units related to SI. At the bottom we have all English units. So 3.6 million joules. So let's pick up this number. 1 therm, that's also electricity, energy. So we can find therm right somewhere here towards the bottom. Yes, 1 therm is how many million joules? Okay, 105.5. Well, 105.51 really. We'll just write down 105.5 million joule. And a gallon, which is about 3.78 liter, is the measure of volume, unit of volume. So we can always go and say how much is a gallon. It should be volume, unit of. So a gallon should be towards the bottom, because it's Englishy. Gallon and meter cube. So a gallon is 3.785 liter. In meter cube, it's 0.0037. It's better to write down. Yeah, anyway, so 3 is I prefer 3.785 divided by 1,000. That's easier to remember. So many meter cube. Okay. Now that we know the conversion, our goal should be basically figuring out 1 million joule of electricity costs how much, 1 million joule of natural gas costs how much, and 1 million joule from gasoline costs how much. So to do so, you know how to launch the DeskCal is right here. And I have already launched it in another tab and also written the test code to solve the problem. Okay, let's go over the code and you will see how intuitive the program is. So first, the given data. The price of electricity is given in dollar per kilowatt hour. Gasoline is given in therm. $1.74 per therm, and gasoline, sorry, that's natural gas, and gasoline is given in dollar per gallon, $3.5. The data for gasoline density and heating value are given in the in kg per meter cube and million joule per kg. As you can see, I have a habit of always putting the units at the end of the variable name. So let's first go through part A. That's the simplest. So we already know price of electricity in dollar per kilowatt hour, and we have just seen that 1 kilowatt hour is 3600 kilojoule. So dividing by that is the dollar per kilojoule, and of course dollar per million joule will be 1000 times that. So this is, as soon as you hit the calculate button, we should be getting price of electricity in dollar per million joule. The price of natural gas, dollar per million joule, is simply dollar per therm, and we know one therm is 105.5 million joules, so that will give us, by the way, the hash symbol means a comment, so you can write anything anywhere and this will be ignored by the program. For the gasoline price, is a little bit complicated because we buy gasoline in volume. So first of all, how much gasoline we buy in mass with that money, and then that mass will produce how much heat. So in 1 gallon, the mass in kilogram in 1 gallon is, we all know mass equals density times volume. So you multiply density with volume. So if we have 1 gallon, a gallon is 3.78 times 10 to the minus 3 meter cube. We saw that already. So that's the volume of 1 gallon multiplied by the density. It'll give you the mass of 1 gallon of gasoline. So therefore, the heat release from that gasoline, million joule per gallon, would be the mass in 1 gallon multiplied by the heating value. That is, when you burn 1 kg, how much heat is released, which is 44 million joules. So we multiply by that. And so we found heat that will be released from 1 gallon. We already know the price of 1 gallon. So therefore, dollar per million joule is simply how much dollar we paid for 1 gallon and how much heat is released from 1 gallon. So that ratio is our answer. So now if we click the calculate button, as you can see, we can compare the three prices. All the variables are found. In case you make a mistake, it'll give you, it will point out where you made the mistake. So price of electricity, it turns out to be this is electricity price, 0.05. Price of natural gas is about 0.016. So this is about 5.2 cents. This is about 1.6 cents per million joule, and the gasoline is about 2.6 cents per million joule. Of course, you can see a million joule of heat is pretty cheap, but you can, as you compare them, you recognize that the natural gas is probably the best way to generate heat if you're comparing these three different methods of generating heat. Gasoline comes next, and electricity is the most expensive way